Today we are learning about a special factoring pattern called difference of squares. Let's break that down real quick. Difference means subtraction. And your squares, we are talking about your perfect squares. So I've left you a nice little chart down here to help refresh you of what those are. Your perfect squares guide. So anytime you say 1 squared and get 1 or 2 squared and get 4, these numbers right over here, what they're equal to whenever you square a number, are your perfect squares. And that means if you take a square root of 1, you would get back to your original number right there. So here's how the pattern works. If you have a subtraction of 2 perfect squares, you can just break them apart and say addition and subtraction of them, and you've got it factored automatically. It's a quick pattern. You just got to recognize it and go, and then you have your factors. For example, I got an a squared and 100. I know if I take, I know what squared makes 100, that's 10. I know what squared makes a squared, that's a. So all you have to do is take that, add it, and subtract it, and you've got your 2 factors. Now why is this working? Well, think about what this would look like with multiplication. A times a is a squared. A times negative 10a. 10 times a is positive 10a. And 10 times negative 10 is negative 100. So this is the pattern that always cancels right in the middle. When they're the same thing with addition and subtraction, your 2 middle like terms cancel out because you get positive, negative, the exact same thing. And you're left with perfect square minus another perfect square. So just remember why the pattern's working, but you just need to get your pattern done. Alright, let's do a couple more. We've got x plus 8 and x minus 8. Because 8 squared is 64, x squared is x squared, of course. There's another way you can write this if you want to be a little quicker. You can actually combine that down to plus and minus. So this stands for 2 things, x plus 8 and x minus 8. Alright, next one, I got 2 things in there, but 3x squared would be 9x squared. So plus 5, because 5 squared would be 25. Then do the same for your subtraction. Another thing I want to point out, I always have been saying add then subtract. You can do that in the other order. You can start with subtraction, then go to your addition later. Here's another one, has 2 variables. Don't let it hold you up. 9a would make 81a squared. And look at 400. 400 comes from 20 squared. So plus 20b and minus it. Again, you can go and say plus and minus for each of these instead of writing them out. Alright, this one's always a tricky one. 121 people recognize, so that's 11x. But 1, a lot of people forget about. 1 squared is also a perfect square right there. So you've got plus 1 and minus 1. It just doesn't look like anything changes there, which is why it confuses people. Alright, last one. It says factor completely. That means usually if you see that word that there's a GCF in there. And yes, I see a GCF right away. When looking at it, they're both divisible by 10. So pull that out from the start. And now this one just seems to be the most common difference of squares that pops out, x squared minus 4. Because perfect square, we've got to take that down to plus 2 and minus 2. So don't forget your last factor there, your GCF, and you have factored it completely. If you want to try a couple, you can make your own. Let's just go over here real quick to some bad examples. This first one's bad because this is a perfect square, but 10 is not. They need to both be perfect squares, every single number you have there. If you try to factor out a GCF to make this work, it actually gets worse. So that would be factored completely for that one. You can't do anything more. Our next one, perfect square, but it's not subtraction, so this one is also not going to work. You're going to have to say not factorable. Alright, thank you.